Hello everyone, this is grade 12 Mathematics University Entrance Examination in English part 17. As you know, it has been a long time since I posted my last video, and today we will see the application of the final question of application of derivative, and we begin with this particular question. Here the question says, what are the radius and height respectively of a right circular cylinder of maximum volume that can be inscribed in a right circular cone of radius 27 centimeter and height 81 centimeter? That is what the question says. Now let us see here the figure. What does this question mean? Let us represent here the cone and the cylinder, the inscribed cylinder as such. Suppose this is a cone, the bigger one is a cone, and inside this cone we inscribed a cylinder. As you can see, the red one, this red geometric figure is, let us consider this as a cylinder which is inscribed inside this cone. Now the question says, for this cylinder to have a maximum volume and they inscribe it in a cone with these dimensions, then what are the radius and the height of this cylinder that must be inscribed with maximum volume and that must be inscribed in a cone? That is what the question says. Now let us make some representation here. So this, as you can see, this one from this point E to point F, suppose we call it the radius of the cylinder, and from this point, it is actually point C to point G, suppose we call it the radius of the cone, and let us represent it with bigger radius. Call this one the point here. Suppose this is the radius of the cone, represent it with capital R, and whereas the radius of the cylinder, let us call and represent it by small r, and also the height of, let us say the height of the cylinder between these 2 points be small h, whereas the height of the cone, it is given already. Let us call this one the height of the cone, this height here, let us call this one b the height of the cone. Now let us say the height of the cone be capital H, and assume the height between the top base of the cylinder to the vertex of the cone, let us call this one be H prime, and we know by definition the sum of the two H prime plus the height of the cylinder is always equal to the height of this cone, since the cylinder is inscribed in this cone. Let us call this one be H. And also we know that here this triangle, a smaller triangle, let us call this one be smaller triangle to this point, and also the larger triangle. The larger triangle means this triangle and this smaller triangle are similar by angle similarity. Here the perpendicular, these are two right angle triangles with their corresponding angle. This angle is congruent to this angle, and they do have again the common angle here, and therefore by angle similarity, these two right angle triangle, this smaller triangle and the bigger triangle are similar. By definition, we know that if two triangles are similar, then the ratio of their corresponding sides must be proportional. That means this H prime, the height here H prime over the height of the bigger triangle, which is actually h capital. The ratio of these two is equal to, again, these are corresponding sides, r small, and these line segments are corresponding sides, and therefore the ratio must be equal to the ratio of the heights of the corresponding triangles. We can write like this one, and then solve for h prime. From this equality, simply solve for h prime, and then the equation becomes like this one: h prime, h small prime, is equal to the ratio of the two triangles, I mean the ratio of the radius of the cylinder and the radius of the cone, which means the bigger radius, I mean, let us write it as such, and simply multiply by this h capital. Once we get this h, the radius of the cylinder, and then we can find the volume of the cylinder. Our objective is to find the volume of the cylinder, and then derivate for the derivative of the volume, for the volume to have a maximum, and then the derivative must be equal to 0. To find, if we have to find the critical numbers, and therefore now substitute this part in place of h prime, which becomes as follows here. Since this h also, that h is equal to h capital minus h prime, and again also h prime is represented by r small, the radius of the cylinder, over the radius of the cone multiplied by the height of the cone, and we can substitute this value into the volume of this cylinder. What is the volume of any cylinder? We know that the volume of any cylinder, the volume of the cylinder is, okay, the volume of the cylinder, this cylinder is equal to area of the base multiplied by its height. But area of the base, since the cylinder is circular, and therefore its base is circle, and the area of a circle is pi r square, and therefore replace AB by pi r square, and the result is going to be, and therefore the volume V of the this circular cylinder is pi r square times h. And since our h is equal to h capital minus r over r times h, let us replace small h by this expression, h capital minus r over r capital times h, and then differentiate this one with respect to r. Find the derivative of this volume with respect to r, and the result will be as follows. I have already done the result, and let us see it together. Okay, now let's see the derivative. Since we are going to maximize the volume of the cylinder, we are going to maximize the volume of this cylinder in order to find the dimension of the cylinder that can be inscribed into the cone, and suppose this VCY be the volume of the cylinder, and as you can see, by replacing this h in place of small h, the derivative with respect to r is going to be 0 to find the critical number, and then the derivative of this with respect to r is 2 pi r capital H minus the derivative of this part with respect to r is also 3 pi h r square over r must be equal to 0, and then here we have 2 pi h and also pi r h, and here we have also pi r small h, and cancel this out, cancel this pi here and h, also h, by dividing both sides by pi rh, both sides of the equation, which means 0 over pi r small r capital H, and here we have pi small r capital H, pi small r capital H, and this will give us 2 minus 3 small r over r is equal to 0. And from this one, let us move this one towards the right, and here we have 3r over r capital is equal to and 2, and multiply both sides by r capital over 3. It becomes, this r will be equal to 2 over 3 times r capital. But we know that here, since the r capital stands for the radius of the cone, and the radius of the cone is given as 27 centimeter, then what we have to do is to find the radius of the cylinder. Just replace r by 27, and when 27 is divided by 3, it is 9. 9 times 2, 18 centimeters. The radius of the cylinder must be 18 centimeter, and but h is equal to h minus r small r over r capital times h, which implies h is equal to capital H minus 1 over r multiplied by 2 over 3 rh, since small r is 2 over 3 r, and replace this r by this expression, and we will get this one, and capital R cancel capital R. The question finally, h small, the height of the cylinder, is equal to the height of the cone minus 2/3 of the height of the cone, which becomes the height of the cylinder in this case is going to be 1/3 of the height of the cone. And therefore, since the height of the cone is also given, as you can see, it is 81 centimeters, the height of the cone, and the height of the cylinder is also 1/3 of the height of the cone, and therefore simply replace h capital by 81, and 1 over 3 times 81 is going to be 27 centimeters. And therefore the inscribed the circular cylinder that must be with maximum volume and inscribed in this cone is going to have the radius, its radius is 18 centimeter, and its height should be 27 centimeter. For the volume of the cylinder to be maximum, then its dimension must be respectively as here 18 centimeter, its radius should be 18 centimeter, and its height must be 27 centimeter. That will answer this question, and the answer is therefore D. And please, next time we'll see unit 3 statistics for grade 12, and until then please try to repeat this question 2 more times until you understand the whole concept. And if you like this video, subscribe and like the video, and also your comment has a lot of value for me, and please leave your comment in the comment section. And if again there are other friends that you have, therefore share this video to everyone that you know. Have a good time. Bye bye.